In this video, we are going to learn microservices distributed transactions. In the last section, we saw that how to decide database, how to scale databases on microservice architecture, and also how to query on microservices in distributed architectures. And now with this section, we will learn how to perform transactional operations across microservices and which patterns and principles we should apply for this action. We saw that querying data and run complex join queries across microservices with some patterns, and it was not easy stuff. Now we are going to learn how to implement transactional operations across multiple microservices, which is more complex. It is complex because of the working on distributed architectures, and working with the polyglot database on microservices can cause to network concerns as naturally. In other words, there is no distributed transaction management on microservices. We should handle it by manually implementing some pattern and principles. Normally, in monolithic architectures, our single database and manage transactions with ACID principles in database level and provide strong consistency. But when it comes to distributed microservices, we are mostly working with the eventual consistency. Since microservices has its own database and communicates with each other exposing APIs, it makes harder to perform end-to-end business cases across multiple microservices when trying to keep data consistency. So how to achieve consistency across multiple microservices? It is good to tackle with this question to see real-world example. You can see the picture on the slide that explains an example of this problem with real-world example in microservices. As you know that we have product and shopping cart microservices into our e-commerce application. So as the picture explained, we are performing two different use cases in here. For example, product microservices include information about the product items when the users adding item into shopping cart, and in the shopping cart product item information include the item product price information and that product price added when user added item into shopping cart. That means the actual product price could be changed after adding item into shopping cart. So when product microservices change the product price into own database, that price information should also be updated in the product items of shopping cart microservices. And also it is good to notify customer that product price changed into their shopping cart. But if we develop on monolithic application, we don't need to do anything when the price changed in the product table. This will automatically reflect to user shopping cart due to use a single relational database which applies ACID transactional principles. In monolithic applications, shopping cart always shows updated price of products and these changes reflects instantly. However, in our microservice e-commerce application, the product and the shopping cart microservices has its own database and there is own table, which is the product and shopping cart tables are stored in their own databases. No microservice should ever include tables owned by another microservice in its own transactions, and also it is not allowed to direct queries to another microservice databases. All communication go through with the well-defined APIs. Product microservices can't directly access a table in shopping cart microservices. So we can't update changed product price to the shopping cart product items. So how can we provide data consistency between only two microservices in distributed environment? In order to update shopping cart microservices, the product microservice should follow the eventual consistency principle and use asynchronous communication with event-based message broker systems and applying the publish-subscribe patterns. So this is how distributed applications perform consistency across microservices. So as you can see that product microservices publish an event which name is price change event, and this will be consumed from the shopping cart in order to update the price changed event into the shopping cart items. So as you remember that according to CAP theorem, we need to sacrifice ACID strong consistency to the high availability and partition tolerance. Most microservice based applications are choosing high availability and high scalability against to strong consistency. Of course, if your business case has mission critical applications that need to stay always updated, then you should follow strong consistency. But mostly in microservices, we sacrifice strong consistency and follow the eventual consistency to get benefits of microservices availability and scalability features. For that reason, NoSQL databases are mostly using in microservices because they can easily and horizontally scale in distributed environments. As a result, we said that even distributed architectures maintaining data consistency across microservices is crucial. In order to solve this issue in microservices, we have to use asynchronous event-driven communication and publish-subscribe pattern following the eventual consistency. At this point, you can revisit to microservices asynchronous communication section to learn all related patterns like publish-subscribe and so on. If we return back to our problem, which is the product price changed in e-commerce application. So when product price updated on product microservices should publish change with product price change event to the message broker system, and this will be subscribed from the shopping cart microservices with following the eventual consistency principle. And of course, this process should be resilient and idempotent for redundant event processing, that we will discuss these topics into microservices resilience section. So far, we have examined data consistency problems into microservices within only 2 microservices. But what if we have to manage consistency between more than 5 or 6 microservices that operates independently? And what if we got problem at 3rd or 4th step of these distributed transaction steps, and how can we roll back the process that executes previous steps? Before deep dive into this kind of scenario, it is good to understand what is microservices transactional boundaries.